Hello, in today's video we're going to be talking about electronegativity and what sort of ramifications an element's electronegativity has on a molecule or a certain bond. For right now we're going to be looking at a certain bond, and then we're going to see what this electronegativity does to that. So, what is electronegativity? Electronegativity is an element's ability to draw electrons closer to it. So if there is a shared bond, let's say between fluorine and chlorine, a covalently bonded system, the fluorine, and I'll tell you why is a little bit later, but the fluorine is much more electronegative than the chlorine. So what ends up happening is the electrons that are being shared around the chlorine, there is not this even sharing going on. The fluorine is actually stealing some of the electrons, or more time with the electrons. It's not an ionic bond, so it's not really stealing it, but it's drawing these electrons closer to the fluorine, which ends up making our electron density look something like this, where the bigger the sphere, the more electrons tend to be around that element. So what ends up happening is we have a partially negative charge on the fluorine and a partially positive charge on the chlorine. If this was an even distribution, even sharing, they would be sharing equally with each other, and there would be none of this partial charges. So with electronegativity and this ability to draw electrons nearer to you, it kind of acts as creating little magnets throughout a system. So if we had a bunch of fluorine-chlorine molecules floating around, we would see that they could line up. The chlorine would be here, the fluorine would be here, because partially positives are attracted to partially negatives, and we end up getting this periodic array of these plus minuses. This is all due to electronegativity. So that's, like I said, is just the ability of this fluorine atom to draw electrons closer to it. So with this, let's see what the trend is on the periodic table. So this is the actual ability of electronegativity. It has huge ramifications in the world of chemistry. If these things were not, if the electrons in this system were equally shared, we want to get this periodic array, this lining up of these molecules. So big ramifications. It also acts very heavily in bonding. So intramolecular bonding. So or intermolecular bonding. Let's see what the trend looks like on the periodic table. So I'm going to draw my crude periodic table here. Looks something like that. Now, electronegativity follows the same trend in the reverse order as size does. We know that size decreases, and this is decrease, going from the bottom to the top. So we know that hydrogen is the smallest element out of the first group, and francium and cesium are down at the bottom. Now, as we move from left to right, we decrease in size as well. So this is size, and we're going to decrease. This is something that we already know. As you move from bottom to top, the size of the atoms decrease. As you move from left to right, the size of the atoms decrease. Well, the exact same trend in the reverse order happens for electronegativity. As you move from bottom to top on the periodic table, the electronegativity, increases. So the smaller you are, the more electronegative you are. And going from left to right, the electronegativity, increases as well. So we have this kind of reverse order. The size decreases, but as the size decreases, the electronegativity increases. And on the periodic table, fluorine is going to be our rock. It is the most electronegative element on the periodic table. And we draw conclusions about other electronegativity based on this atom. So the further you are away from fluorine, the lower your electronegativity. The closer you are to the fluorine, the higher your electronegativity. So we can easily see a bond between carbon and fluorine. The fluorine is going to be more electronegative. If we look a bond between carbon and oxygen, so carbon would be somewhere around here, oxygen, carbon would be somewhere around there, nitrogen, oxygen, fluorine. The oxygen is closer to the fluorine, which means the oxygen is going to be more electronegative and the carbon is going to be less electronegative. So we're going to be drawing these conclusions and seeing, as we start drawing Lewis dot structures, how this plays in the interaction. And it has special ramifications for molecules in the way that they bond with other molecules surrounding them. So with that, I want to say that's all we're going to talk about electronegativity. We'll do a few problems tomorrow. We'll introduce a few other concepts. And then next week, we're going to start with drawing the Lewis dot structures. So with that, I want to say have a great night. I will see you all in class tomorrow.